All right, so here with the least common multiple, okay? So again, what we're doing is we're working in section 1.1, which is basically linear equations. And now what we're up to is the least common multiple. Basically here again, some of these equations, as you'll see today, do involve fractions. And to me at least, a real efficient way to solve a kind of an equation, a linear equation with fractions in it, more than one, is you can just multiply by the least common multiple, which essentially is of the denominators, which is essentially just the least common denominator. Okay, but again, you can multiply both sides by the least common multiple of the denominators. Okay, and again, I went over what the least common multiple was. You know, it's still here on the slide, of course. And again, if you have two non-zero integers, okay, basically the least common multiple, remember, is, excuse me, it's the smallest positive integer that's a multiple of both m and n. So the least common multiple of m and n, these are the two non-zero integers. It's the smallest positive integer, which is a multiple of both m and n. Okay. So it's the smallest positive integer. That's a multiple of both m and n. That actually applies also if you had more than two integers here, more than two non-zero integers besides m and n. You know, again, it's the smallest positive integer that's a multiple of all three, or even all four, and so on. Now, even though 0 is up here, I guess really in a sense I should not have included it, but it is technically part of the definition because 0 cannot be the least common multiple. There are fancy ways to find the least common multiple using number theory. But for us, all we can do is this. We just list out the multiples of each number until we find one that's in both lists. You know, the smallest integer that's in both lists. You know, for 6 and so for 6 and 8, for instance, right? For 6, we have 6, 12, 18, 24, 30, 36. I kept going up to 48. For 8 here, we would have 8, 16, 24, up 24. 24 is a common multiple, right? And it's the first one in both lists. So 24 would be the LCM of 6 and 8. Okay, so that's what we get here. I mean, if you didn't find a common multiple, you could just keep listing elements. You will find one. You will. Okay, so that's for 6 and 8. For 12 and 10, right, we list the multiples of each. We have 12, 24, 36, 48, 60, 72. I mean, really, I guess we could have stopped at 60 because you probably know 60 is a multiple of 10. But you can list the numbers of 10 as well, just to be sure. 10, 20, 30, 40, 50, 60, right? So because of that, 60 is the first number in both lists. So because of that, 60 is the LCM of both 12 and 10. Okay. Now, let's actually solve an equation using the LCM. Okay. So here we have this equation. As you can see, we have x plus 4 over 3 plus 2 times x minus a fourth. That's equal to 3x plus 2 over 6. Okay? So we have to get the least common multiple of 3, 4, and 6. Okay? So what I did again was I just started listing multiples. Okay? I don't know why I put 27 in as a multiple of 6. That just came out by mistake. So we have 6, 12, 18, 24, 30. You know, I kept going until I got to 6 times, what is that, 12? Okay. And for 3, we have 3, 6, 9, 12, 15, 18. Oh, we have 12. Well, we also have 6s in both of these. Okay, so maybe 6 could be a the least common multiple of all 3. But don't forget about 4, right? We have 4, 8, 12. So 6 is not a multiple of 4, but 12 is, right? You can see that 12 is the least common multiple of 3, 6, and 4, right? It's the first number in all 3 lists. It's the first number in all 3 lists. Okay. So we have 12 here. Okay. So 12 is the LCM. Again, 12 is the first number that appears in all 3 lists. So it's the least common multiple of 3, 4, and 6. What do we do next? What we do next is we're going to have to multiply both sides by 12. Okay, and that's what I'm doing down here. Remember, when solving these equations, right, there are certain manipulations you're able to do, okay? And you can only do those manipulations. You can simplify either side of the equation. You could interchange both sides. You could add or subtract the same thing to both sides. You could. I know there was something with the domain of the variable, but that's really not going to be an issue for us in this class. Or you can multiply or divide by the same non-zero number, right? And those are okay because you're not changing, you're not affecting the solutions at all. All right. So here what I do is I multiply both sides by 12. And now I'm going to distribute, right? So we're multiplying, so we distribute. We have 12 times this, plus 12 times this, plus 2x times 12, minus this times 12, right? We have to distribute. And that's how we get the next line. You know, we're simplifying a bit. We're messing around with the left-hand side. Okay, so what happens here? Well, what we have here is we can cancel, right? We're multiplying, so we can cancel the denominator with what we're multiplying. So in other words, 3 and 12, right? 3 is gone. 12 we know is 3 times 4, so 12 becomes 4. We have 2 times x, right? And then we have 12 over here. There's no denominator, so let's leave that alone. Yeah?
What time are you putting up the test? I'm sorry, I just joined.
2 o'clock.
Oh, okay, thank you.
You're welcome. That's okay. So here, so we have 12 times 2x, and here we have minus 1 over 4 times 12, right? What do we do next? Well, again, there's going to be some cancellation, right? The 4 is going to be gone. 12 is 3 times 4, so that's going to become 3. Same thing on the right side. Over here, we have 6 and 12. Well, 6 goes away. 12 is 6 times 2, so we're left with 2. So that's what we have here. Good. Okay, so what's next here? Well, we go to the line below, right? We have 4 times x plus 4. That came from here. So we have to distribute again. Okay. 12 times 2x, that gave us the 24x. Here we had 3. We have minus 1 times 3, which is minus 3. Here we have 2 times 3x plus 2 times 2. Yeah?
Can you just go back to the step before it and explain it again? I'm sorry.
Up here?
Yeah, just that step. Yeah,
So here we had 12 times x plus 4 over 3, right? Now we have 12 times that. So what we can do is cancel, right? Because we know that 12 is 3 times 4. So basically the 3 cancels, and from 12 you're left with 4. Here we don't cancel because there's no denominator. Here we have 4, right? And 12. So we cancel the 4, and 12 we're left with 3. Because 12 over 4, 12 divided by 4, maybe that's better. 12 divided by 4 is 3. Over here, 12 divided by 3 is 4. Here, the 6 cancels with 12. 6 is gone. 12 over 6 divided by 6 gives us 2. So that's what we're left with. And that's how we get down here.
Okay, thank you. I was just confused what you did, but I understand now.
That's okay. Thank you. Glad you asked. No worries. Good question. Okay. So again, down here, we're distributing, right? And from here, what's going to happen? Well, we're going to get the laser pointer. We get 4 times x plus 4 times 4, which is 16, plus 24 times x minus 3. 2 times 3x is 6x. 2 times 2 is 4. So we have this equation now, okay? All right. Now remember, what we can do here, we can keep on simplifying the left-hand side, right? We have some like terms here. Let's put them next to each other. So we have 4x, 24x, they're like terms. We put them next to each other. We have 16 and minus 3, they're next to each other. And now we combine like terms. So 4x and 24x, that gives us 28x. 16 and minus 3, that gives us 13. 6x and 6x and 4, you know, they're not like terms, so we just leave them alone. Okay, so we can't do anything there.